on that exam, there's going to be at least in 2 places, probably 3 places, a basic collision problem. And they look like this. You got a couple of blocks, they hit each other, and you got to figure out how fast one of the blocks is moving afterwards. Now, this is one version of this problem. I could also give you both velocities after the collision and leave out one of the initial. That's just another way to dance this problem. You should be able to solve this basic collision problem very, very quickly. This should be almost trivial to you. With your neighbor, make it so. Okay? Do it. Do it. How many of you are sitting next to someone who's got an answer already? Okay. Starting to get there. Let's do it together. This is a collision, so momentum is conserved. Momentum is a vector, so I need a coordinate system. I'm going to call to the right the positive x direction, to the left negative x. The equal sign is the collision. Everything to the left of the equal sign is the top picture. To the right of the equal sign is the bottom picture. So before the collision, I have 3 kilograms moving at 5 meters per second. It's moving to the right, so that's positive momentum. I also have 12 kilograms moving at 4 meters per second, and it's moving to the left, so that's negative momentum. Then the collision happens. After the collision, I have 3 kilograms moving at 3 meters per second, and it's moving to the left, so that's negative. After the collision, I don't know whether that blue block is going to the right or to the left. And so what I do is I assume a positive variable, V final. And I say that the momentum of the blue block is 12 kilograms times V final, and I assume it's to the right. Now, if I solve for V final and I get a negative answer, I'll just know that I assumed wrong, and that it's actually going to the left. Okay? Now this is going to be 15 franci minus 48 franci is equal to negative 9 franci plus 12 kilograms V final. This is negative 33 franci is equal to negative 9 franci plus 12 kilograms V final. I add 9 to both sides, I get negative 24 franci is equal to 12 kilograms V final. That gives me a V final of minus 24 over 12, or minus 2 meters per second. If you have a coordinate system on your page, you will get full credit for this answer. This would be the magnitude And this minus sign would be the direction of your final velocity. However, you will always get full credit if you say V final is equal to 2 meters per second to the left. That would be the magnitude, and that would be the direction. If you write your answer that way, you don't have to have a coordinate system on your page. That's right. Okay? Well, it's left. Okay, so the answer is 2 meters per second to the left. Now here's the point I want to make. The momentum of the red block is not conserved. It went from 15 to the right to 9 to the left. That's not the same. The momentum of the blue block is not conserved. It goes from 48 to the left to 24 to the left. That's not the same. It's only the momentum of the system. When I add up the momentum for both blocks that I get minus 33 before and after. Okay, that's what it means when the system momentum is conserved. Now there's another way I can dance this problem. I can say, well, what if they stick together and move as one ugly unit with a mass of 15 kilograms? How fast would they be going? Well, if I go back to this derivation we have here, everything on the left-hand side of the equal sign is still the same. I still have the same initial velocities, okay? But now, after the collision, they're moving together. And so I can solve for V final. It's going to be negative 33 Franci over 15 kilogram. And that's going to be negative 2.2 meters per second, or 2.2 meters per second left. Okay? Now again, you should be able to do that very quickly. Please check that your neighbor has that skill.